So you went through glycolysis and what I refer to as the junction, and now you've got your acetyl-CoA. And you can start the citric acid cycle, which is the first technically real step of cellular respiration. And so you're going to start out with an oxaloacetate. I'm not starting out with the acetyl-CoA because really the oxaloacetate is what you're joining up with first. So that's what we're starting out with. And the acetyl-CoA will go in, and then CoA-SH will go out. And you'll end up with citrate, which citric acid cycle, citrate, see where that ties in? So citrate will release a water, but then the water will go back in. And this is to convert citrate into its isomer, isocitrate. And isocitrate will be oxidized by NAD+, and it will have an NADH and H+ taken out of it. And then you lose a CO2 as well. And you create alpha-ketoglutarate. Alpha-ketoglutarate will lose a CO2, and then it will be oxidized by NAD+. And finally, a CoA-SH will be added back in. But the bond is so unstable that it's not going to stick around for a long time. But you'll have succinyl-CoA. Now, with succinyl-CoA, a phosphate group will jump on board, and then a GDP will come in, and it will steal away that phosphate to create GTP. That will then meet with an ADP, and the ADP will take away that phosphate to create ATP. The GTP is stripped of its phosphate, so it will go back to GDP, and the cycle will then start over again. So that's a cyclic part of the citrate cycle, citric acid cycle. And additionally, that unstable bond that CoA-SH had will be broken, and CoA-SH will float off into the wind. And you will have succinate left over. Succinate will then meet up with FAD, which will steal away 2 hydrogens and oxidize the succinate to form fumarate. Fumarate will then steal water away and create malate, which will then be oxidized by NAD+, and you have oxaloacetate again, and the whole cycle will start over. And that's the citric acid cycle. As complicated as it seems, it's just a lot of steps, doing a lot of stuff.